This video contains information regarding drawing symbols and tolerancing. Rather than strictly geometric dimensioning and tolerancing, this is more of an overview of more commonly used symbols and tolerancing methods. After watching this video, you should have an understanding of datums on drawings, hole and depth symbols, simple ways used on engineering drawings to cut down the amount of information written on them, nominal sizes of a feature, different types of tolerances that may be found on a drawing. Here we can see a basic part drawing showing feature sizes, tolerances, symbols designed to convey information. On the first of the two elevations you can see a cross formed of dashed lines. This shows the position of the center of the circular features. They are known as center lines. The dashed lines on the second elevation are used to represent hidden features. That is, features that this view would not be able to see. This picture shows the three datums used in the drawing. A datum symbol consists of a filled triangle connected to a square box by a solid line. In the box we find a letter such as A, B, C used here, but could also be other letters. A datum establishes a line, side, or face that the measurements in a single direction, or plane are to be made from. In the original drawing we have measurements running in 3 planes, so the drawing has 3 datums. Here we can see a number next to a diameter symbol. The number represents the size of the diameter, given as 15. There is no tolerance given. In this case, the tolerance should conform to a general tolerance given in the title block of the drawing. The title block should also state what the unit of measurement the size should be in. For this video we will assume it is millimeters. So here we have a generally tolerant circular feature with a diameter of 15 millimeters. This time, rather than a diameter symbol, we have the letter R. This is to denote radius, which is half of the diameter. We also have following the size, times 4. The is a filleted corner and the times 4 is telling us there are 3 other filleted corners of the same size. This is simpler and less cluttered than putting this size on each of the 4 on the drawing. It is done to make the drawing clearer and more easily read. Instead of times 4, we could also write T, Y, P. This is short for typical, and tells us that all features on this drawing that look like this and are not dimensioned are the same size as given here. In this example we have another diameter at a size of 10 millimeters. The symbol that looks like a T with an arrow head at its base tells us it is a hole. This is a depth symbol, and the following number, also 10, tells us how deep the hole should be. In this example we can see 2 lines with a double-ended arrow between them. This tells us that it is a length or width of a feature. The number 8 being this length. Following this we have a tolerance. The plus or minus symbol tells us the allowed tolerance deviation is the same in both directions. In this case 0.01 mm in each direction. So the maximum the feature can be measured is 8.01 mm and the minimum it can be measured is 7.99. If the feature is not within this range, it is outside tolerance and the part would normally be scrapped. Here we have the same arrows connecting lines and signifying a length or width measurement. Again we have the nominal value, this time it is 17. However, the tolerances are mismatched, with a value of 0.1 mm above and 0.2 below. The tolerances in this example are deviation tolerances, rather than symmetrical tolerances in the previous example. A machinist or CNC programmer will often set their nominal value halfway between the upper and lower limit, as this gives the best chance of making a part within tolerance. Finally, we have a box symbol at the end. This tells us that the feature dimensioned is a square and all 4 sides are as the measurement given. In this example we are not given a nominal value. The upper number is the high limit of the tolerance and the lower number is the low limit. In this case we must derive the nominal value. Much as given in the previous example where the machinist or CNC programmer would set their nominal value halfway between, we derive the nominal value as being halfway between the numbers given. In this example that would be 9.85. This example is similar to the previous one, giving us the lower and then upper limit. We would derive the nominal value in the same way, as halfway between. It is only the layout that differs. We should now be able to read all the information needed on this drawing. It should be noted that it is rare to find one drawing with lots of different tolerancing styles. Most authors of a drawing would stick to only one or two methods for simplicity. Looking ahead, the next videos in the series will go through the basics of geometric dimensioning and tolerancing, looking at the symbols and uses or reasons for each. This video is intended as a recap on the more normal tolerancing, dimensioning, and drawing symbols used as a basis to work from.